Here's the guts of a Ryobi P117 OnePlus system battery charger, and fairly similar overall to the P118, which this is just a higher power, shorter charge time version of, but there are a couple of differences. First off, the front end of the power supply in it uses a potential double rectifier and runs on about 320 volts DC or thereabouts instead of the regular Graytsbridge rectification that the P118 used, and that only had one ripple suppression capacitor, of course. It also uses a bit bigger diodes because the main side current is about, I'd say probably about 750 to 800 milliamperes RMS, so which would be a bit much for continuous use on 1 in 4007s, which the P118 used. So this uses 1 in 540s, which are just 1000 volt 3 ampere rectifiers. Are basically the 3 ampere version of 1 in 4007. And that extra jumper wire is for the potential double rectifier. Other than that, fairly similar common mode choke, mains QRM suppression capacitor, NTC for inrush current limiting, metal oxide varistor for input surge protection, input fuse. These are generic Samsung crappy electrolytics. But then again, made in China to be expected. Current sense resistor, I'm thinking, for the switching device. This uses a 6-pin monolithic switch mode IC, which I think the other one also used. It wasn't just a plain fit, like I said in the video. Then there's a opto for output. That's just for output side sensing for regulation of the IC, and just one switching device, so it'll be single end drive. That's seems to be fairly typical on these smaller power supplies. Transformer Y caps, which are just very high reliability ones that will almost certainly not fail short barring really extenuating circumstances, and that's just a safety thing, so that if one of those things fails, it doesn't inadvertently connect up the output of the thing straight to mains. And like in the other one, this marks it as a CY2, so the silk screen actually denotes it as being a Y capacitor. A couple of output idiot lights, over temperature, charger on, and charge state, which shine into a series of little light pipe assembly there, instead of just having little holes in the label that the other charger had. And like the P118, this has a one of these memory metal, or not, amorphous metal anti-theft thingamajigs. I thought it might be for some kind of inventory control or something. That's kind of weird, and you don't usually see them incorporated in products like that. But whatever. There's a current sense resistor, Moralytics. That is a 78L05 5-volt potential regulator for the micro, which is on the other side that I'll get to in a bit. A relay. It doesn't actually show what the coil potential is on that. It's unusual. Anyways, then there's a... The colors go all funny. But anyways, contact assembly. That split contact is for the battery neutral or relative negative, and that is just a means for the charger to tell that something's in there. Is that and that is a fairly common technique in things like connectors, as far as if you want to tell if it's plugged in or not. is what happens is that these two are bridged together when you put the battery in. And one of those is connected to the power supply. The other one, looking at the traces, goes straight into the micro. And what it is that's held at, say, something like 5 volts by a pull-up resistor, or 3.3 volts, or whatever the operating potential of the device is. And what happens is that when the thing is when the battery is inserted, that shunts those out and pulls that terminal of the micro to ground, and tells it that it's that there's a battery in it and that it should charge. And there's a overcurrent protection fuse. Again, the other contact, which is used on the lithium batteries. ICSP header. Ceramic resonator for the micro. Another diode and a bunch of jumpers. And don't exactly know what that really does. And there's a bridged over inductor right there. And the date code on the PCB is week 4, 2013. On the underside there's the micro. Don't really recognize the manufacturer. It is if I can get it to show up on camera. Don't recognize the it's a BJBF 103LQ32, or that's either a Q or a 0, can't really tell. I guess it's going to be some obscure manufacturer micro. Like the P118 used a ABOV, which never really heard of. Although I've seen references to them in the past, like I think in an EEV blog video or something. But anyways, there's the trace that I mentioned. It just goes. That one's the power one that goes straight to the shunt, and then those are the I think the 2 Kelvin connections for the current sense resistor. And then that just goes straight into the micro. So I'm guessing because there's no external resistor, that's probably using a weak pull-up in the micro, because lots of them have that. Bunch of passives, another one of these AS324, LM324 clone operational amplifiers. That's probably just being used as buffers and buffering and filtering and whatnot. There's some transistors, diodes. There's a Zener. That's just various regulation circuitry for controlling the what is it? The opto. And there's a slot under the opto because, as far as increasing clearance and creepage and whatnot, because with components like that, especially one with a ventilated case like this, crap can get in there and greatly reduce the dielectric breakdown of the just across the surface of the PCB. And so that slot just helps to prevent that. That's just as far as safety stuff, so that again you can't get flashover between main side and exposed to meat space contact side. And likewise with these holes drilled under the transformer. And get another of these series of pointy contacts with no solder mask. So that on the P118 as well, don't know exactly what that's for, because it's looking kind of like some of the microwave black arts, black magic stuff that you see, except this thing, even the QRM and just deal with is many decades below that, and so I don't see what exactly that would do. So who knows, maybe some of the people watching this might know and they can say in the comments, hint hint. And what else? And not really all that much else to So on this thing there's a couple of current limiting resistors for the three idiot lights, a couple 474,000 ohm bleeder resistors across, 470,000 ohm bleeder resistors across each cap. Likewise, that's just 470,000 ohm resistors. That's just bleeders so that you don't draw down the charge on the ripple suppression capacitor when, or no, on the QRM suppression capacitor that's wired there and then, so you don't get a nip on the off of the plug if you just unplug the thing. And you can find ICs that are designed to do that, where they're designed to be open circuits, and when there's AC potentials across them, and as soon as they see a DC bias or a DC potential for more than a few hundred milliseconds, they turn on a FET switch and effectively short out the two pins or the device, and that's used as a very low or a very low loss equivalent to these, except this is nearly 1,000,000 ohms, so there's going to be on the order of, microamperes, like a few hundred microamperes of current through those two resistors. So things like that are really kind of just gilding the lily as far as absolute maximum possible efficiency, but then you're running into issues like just cost and kind of the law of diminishing returns and whatnot, so it makes more sense for them to employ just plain old resistors. And also this one is also flow soldered like the last one was, because you can see that there's blobs of a goo or adhesive under really all of the ICs and all the surface mount devices on this. But it's a thing.